there, this is Rachel, and I'm the chemist over at LCSC. And I've heard that you've been working on doing some separations for Clearwater construction. And I'm here to tell you a little bit about some of the chemistry backgrounds for the separations you've been doing. So I think that the first time you did a separation into or taking a solution and separating it into water and a pure compound, you ended up with these crystals that had X's through them, and those were table salt. And the question was, this time, did you still wind up with table salt? And I think probably when you did when you got your crystals, they had this kind of needle-like quality, or at least some of them did. Now, there's a variety of different reasons that different types of matter looks different. And so you're probably familiar with water can look very different depending on what phase it's in. So you could have steam, and that's going to look different than ice, and that's going to look different than liquid water. But all of those are the pure compound water. In the case that you've been working on, where you have these two different solids, these are actually made out of different types of these very small building blocks of matter that we call atoms. They're made out of different types of atoms. And so the one that you started with was table salt. And table salt is made out of atoms that are called sodium and chloride, whereas on the crystals that you of the pure compound that you separated most recently, those are composed of magnesium and sulfate and sulfur and oxygen, pardon me. So there's actually a lot of different types of elements out there, and they're arranged into something that we call the periodic table. Each of these little squares is a type of atom called an element. And the most common ones that we find, for instance, in our body, and that the animals and plants that are around us are composed of, are carbon, nitrogen, oxygen, and hydrogen. And they're represented in this periodic table just with the first initial of their name. Now, sodium is actually represented with Na for historical reasons, and sodium and chloride were the two elements that made up your table salt. And then magnesium and the sulfur and oxygen are what makes up those needle-like crystals. So the two different pure compounds that you separated from water, those look different because they're actually made of a different type of atom. So atoms are really small. We can't really look at them directly. And here is, zoom out a little bit. You can go back in. All right, let's see here. I'm looking at a scale drawing here. And here we are up at the size of elephants, pardon me, dinosaurs and whales and big trees. And if we zoom in, we see the size of ourselves. We're a little bit smaller, and we keep going in, getting smaller and smaller, size of eggs. Eventually we'll hit things that are small enough that we can't really see them just without any help. So now we're at that level, and we keep getting smaller and smaller. We need help seeing these things that are in front of us now. Get even smaller and even smaller, and now we're at viruses, which we can't even see with a regular old microscope. And we keep getting smaller and smaller. DNA, and now we're finally at the level of these atoms, and sometimes we call this the atomic level. Now there's actually a lot more room to zoom in even more, and we could look at smaller and smaller objects. There are a lot of things smaller than the atoms, and that's a whole other universe to explore. Now, even though the atoms are too small for us to see them with our eyes all by themselves, we can see them by using a special technique called scanning tunneling microscopy. And so here are two examples. We have silicon, and we have nickel over here on the right. And these were both taken with data taken with a scanning tunneling microscope. And so these are actually individual atoms that are being pictured here. So Good work in your separations. If you have any questions, let me know. And I hope this helps with writing your claims and evidence.